Hello guys, I hope you're doing well. And here we are back with another example, or some more examples, on differentiation using product rule. Yes, I said product rule. It says here, show that if y equals tan x, then dy dx equals sec squared x. Where's the product? Where is the product? Well, let's first of all rewrite tan as something that we do know using an identity that we are familiar with. So we know that tan x is equal to sine x over cos x. But again, I ask, where is the product? This is dividing. This is a quotient. What's going on? Well, we can write this as sine x multiplied by, just to make things easy, I'm going to write it like this, cos x to the power of minus 1. Right, now we can see it's a product. Okay, so we let u equal sine x and let v equal cos x to the power of minus 1. Then we let du dx equal cos x, because sine x differentiates to cos x. dv dx, well, this was an interesting one. This is the chain rule. So this minus 1 comes in front. So minus 1 times cos x, take the power down by 1, so it's to the power of minus 2. And that is multiplied by the derivative of the inside. So minus sine x. Let me just write that over here. So that's equal to, let me just do this. That is equal to minus 1 multiplied by cos x to the power of minus 2 multiplied by minus sine x. The minus sine x, remember, because cos differentiates to minus sine. So simplifying that, that becomes sine, because minus 1 times minus sine is just sine x multiplied by cos x to the minus 2. Now, dy dx is equal to u times dv dx plus v times du dx. Okay, so we've got u, which is equal to sine x. So we've got here sine x. dv dx was equal to sine x multiplied by cos x to the minus 2. V was equal to cos x to the minus 1. So cos x to the minus 1. du dx was equal to cos x. Okay. Now, we've got, if we simplify this or a little bit, we get sine x times sine x, which is sine squared x. Cos x to the minus 2, well, that's 1 over cos squared x. So multiplied by 1 over cos squared x. Plus, we have cos x as normal here on the right. And cos x to the power of minus 1 is 1 over cos x, just to make things a little bit clearer. So this simplifies to sine squared x over cos squared x plus cos x over cos x. Okay. At this stage, there are many things we could do. We could, if we really wanted to, simplify cos x and cos x, giving us 1, and then having this as tan squared x, and then knowing another trigonometric identity, that would help. But so that we don't have to use any identities that are a bit too wild at this stage, I'm actually going to make the fractions have the same denominator. So we have sine squared x over cos squared x. And then I can make the right fraction also have a cos squared x. So if I multiply top and bottom by cos, I get cos squared x over cos squared x. This becomes sine squared x plus cos squared x all over cos squared x. And we know that sine squared x plus cos squared x is 1, and that's divided by cos squared x. And lo and behold, 1 over cos squared x is the same thing as sec squared x. So we have shown that if y equals tan x, then dy dx equals sec squared x, like that. Okay, let's go through another example. So let us take this wild looking example and we'll call it, so we've got y equals e to the power of x divided by the square root of x plus 1. Okay, so now of course we want to work out the derivative of this. This doesn't look quite like a product, so I'm going to rewrite it like a product first. So that is the same thing as e to the power of x multiplied by x plus 1 to the power of minus a half using laws of indices. Okay, and now we will let u equal e to the power of x and let v equal x plus 1 to the power of minus a half. Okay, so we have now du dx is equal to e to the power of x. Then we have dv dx, using chain, is minus a half x plus 1 to the power of minus 3 over 2, because we're taking away 1, multiplied by the derivative of x plus 1, which is just 1. So the final simplification for this little bit is minus a half x plus 1 to the power of minus 3 over 2. Okay, and then we have that dy dx, the rule, the chain rule first of all, the product rule rather, is u dv dx plus v du dx. So u was equal to, I'm just going to change color. Let's go green. U is equal to e to the power of x. dv dx was equal to minus a half x plus 1 to the minus 3 over 2. And then v was equal to x plus 1 to the power of minus a half multiplied by du dx, which is e to the power of x. Okay, and then that becomes minus a half e to the power of x times x plus 1 to the power of minus 3 over 2 plus e to the x times x plus 1 to the power of minus a half. Now this is officially differentiated, but we can take it just a little bit further, just a little bit further, where we can simplify. So I can say this is minus a half e to the x over x plus 1 to the power of 3 over 2 plus e to the x over x plus 1 to the power of a half. Then it just makes it much clearer to see what we're going to do. So I can now factorize 1 over x plus 1 to the power of a half, and also factorize out e to the x. And then inside, I have minus a half over x plus 1 plus 1. So if I were to add the fraction in the box, I'd get e to the power of x over the x plus 1 to the power of a half. And then here, I'd have minus a half plus, if this 1 becomes x plus 1 over x plus 1, that becomes minus a half plus x plus 1 on top. And it's all over x plus 1. If you're not sure about that yourself, just consider this as algebraic fractions and maybe slow it down to add those fractions. Okay, then we have e to the power of x over x plus 1 to the power of a half. And then here we have x, 1 minus a half is a half, so plus a half over x plus 1. Okay, and that is actually quite good. I mean, you could also write it like this: e to the power of x, multiplying out this bracket, times x plus a half all over, and then they're both x plus 1s, so you've got to the power of 1 down here and to the power of a half, so adding those powers becomes x plus 1 to the power of 3 over 2. Now, at this stage, we were just playing around, manipulating the function. You don't have to get it to this stage. The only time you would have to get it to this stage is if a question, an exam question in particular, specified that you have to get it in that form. Otherwise, we were all good at this stage. This stage was fine. Okay. And that is it for this video, guys. Take care for now.